Hey, good morning, folks. Core got out on time today, so hopefully we'll see people showing up here pretty quick. Ronan, that the deep scrub thing that you mentioned in stand up, is that discussion happening on the mailing list or is that was that private emails?
Actually on the PR itself.
Oh, on the PR. Okay, okay. I have to apologize. This morning I was supposed to be in a 2 hour meeting that got canceled at the last minute, but I've been busy with actually exciting things that we'll talk about today with Adam. But I didn't go through PRs at all, so I don't have any updates on that. The last couple months I've been kind of slacking on going through PRs, so I apologize for that. But
It's
hopefully.
not in the list anyway.
No, no, I haven't updated the list, so um, I'll I'll try to be better next week about that. But yeah, hopefully the trade-off is worth it. We've got some exciting things to talk about today, I think. So um, anyway, it looks like we've got people from Core now, so this is good. Uh, all right, so uh, I guess since I don't have any PRs to talk about, I'm going to dive right in. Um, we had a really good meeting last week where we talked about all of these issues surrounding snapshots and ideas to try to make it faster in the OSD, or potentially specifically with RBD Mirror, ideas to maybe make RBD Mirror faster without relying on snapshots. So I think just as a quick recap of last week, um, all of us kind of had different ideas about things that we could try to make this better. And uh, we started working on some of those. I ended up working on defragmenting objects prior to snapshot with the hope that I could reduce the number of extents and the number of shared blobs periodically by doing a copy. And that ended up being kind of interesting. I'm going to actually talk about it before we get to Adam's stuff, because Adam's approach ended up being so amazingly good that if I presented mine afterwards, I think it would just kind of be really unimpressive. So um, I'll start out, and then Adam, I'll give it over to you after that. Um, so okay, uh, I'm going to share my screen here. If you can see this, the gist of it is when I started implementing uh, the defragmentation. This is really stupid and simple implementation. It's just uh, if we see that the number of extents has exceeded some threshold, then we will read the object and rewrite it out, basically, and rewrite it out in a defragmented way. So um, it's that's all it's doing. This DT value that you see in this graph is the threshold, and then DJ is jitter. So basically, I made it so that there's some random Monte Carlo like aspect to this to make it so that we don't have just a stampede of object writes all at once. Hopefully, they spread it out a little bit more. So you can see in this first graph here that it is effectively reducing the CPU usage. Its baseline is maybe in this test around 100% one core, and we're dropping from about 2.5 cores down to closer to around 1.5 cores. So it is a CPU win, for sure. Um, one of the big concerns with an approach like this is that when we copy the object and sever the object from the snapshots, we use more space on the disk, for sure. When we have a very low threshold, it's quite a bit more. In these tests, we have a 5 gigabyte volume and up to 5 snapshots. Once we hit steady state, it's always 5. So if you were just copying objects, it'd be 30 gigabytes of disk usage. When we have a fairly high threshold, like in this red and yellow graph, we can actually get fairly close to kind of the baseline case where we only have copies for extents that have changed. There's a little bit of kind of fluctuation as we go along here, but it tends to even out over time. And we're a little bit higher. It's not too bad though, so that's not really a problem. Maybe it is a little bit, but it's not a major space amplification. But the bigger concern is right amplification. When we copy objects, we end up actually invoking a pretty big workload on the disks. When we have this kind of jitter approach where we add jitter in, we can kind of smooth it out. So this yellow line, you can see that when we do a snapshot, at least temporarily, we're using about 100 megabytes per second of disk I/O to copy objects. Not ideal, but if we were able to further smooth that out over time, we could probably drop that down. If we could make it more of a background constant workload. There's some possibility there. So this does help. If we actually look at the client level IAPS, both read and write, you can see that the blue is our default case, and in the red, yellow, and green cases, we don't see as much. We don't see as many stalls. This is on NVMe. On HDD, I suspect that all of this looks a little bit different, but at least as far as the code goes, this does appear to be helping. It's not, there's some value to it. It's not going to look nearly as good once you see Adam's results, but still, it's not bad. I think if we want to continue pursuing something like this, it'd be better to transition this to some kind of a background process where we very slowly go over and look at onodes that are heavily fragmented, and then maybe see if we can make it better. And that might still actually even possibly be some might provide some advantage even with Adam's code, but it'd need to be a very slow process, I think, much slower than even this 0.8 case I've got here. We'd want it to have as minimal disk impact as possible. So that's what I did over the last week. Let's see. I don't think I can probably hear anyone, but if anyone has any questions, I guess put them in the chat window.
Testing. Mark, can you hear me?
All right, I don't see anything. So, Adam, do you want to take over and talk about what you did?
Yep, gladly. Guys, I hope I can get some sign that you can hear me, otherwise that will be futile. Basically,
we do.
That's great. Basically, last week we had a great brainstorming session, and one of the ideas was to make completely different approach to tracking shared allocations with different objects. The idea was to, instead of have each shared blob, each blob track its own allocations with the other users, making, and that's required to convert a standard blob into shared blob. We decided to just try how will it work if we had just one object, some tracker that will track the data for all the allocations for all that object and all the clones, snapshots of that object. So then we have, in that sense, after we start making a snapshot of an object, we just have a class of objects joined by a common tracker. the expectation was that it will be somewhat good, and it will require some further improvements. But the idea was, the concept was that we could somehow move the load from shared blobs to some just CPU intensive actions that will be contained into just one place. We could then improve that. But it turned even better than expected. I would prefer if Mark was showing this. Maybe I will write him. Well, certainly today is a difficult session. In the meantime, my branch seems to work. It only now has a problem that its FSCK is basically asserting, and not it's still okay, but the tests are getting wild because they do find unexpected results. So I cannot do full proper Ceph object store tests. But for what I can ascertain, it's just the logic of snapshots and containing different tracking properly and containing different data in different snapshots is working properly. So now there's only a thing of Mark presenting the comparable results with his setup.
So the CPU usage is really, really low, much lower than it was in my PR. In fact, it's kind of amazing. I don't think either Adam or I could believe just how good these results are. It appears that like all of the usage that we're seeing in the default case in main is primarily due to shared blob refs. It's pretty crazy. No space amplification whatsoever, as expected. For write IOPS, we don't see any additional write load on the disk as you'd expect. These drops that we see that happened in my test cases as well. It looked like it was maybe a little bit diminished versus the default case, but we're seeing it kind of consistently across all versions. Interestingly, though, that doesn't appear to be correlated really with the client write drops. Maybe a little bit. I mean, we kind of see something here that could be correlated with like at maybe the 8,000 second mark roughly with what we saw in the block device write drops here, but we don't see it in like the red case with Adam's chart tracker. There was a drop in the block device write throughput, yet there's no correlated client write drop. So it's still a little bit of a mystery what's going on there. But the good news is that similar to in my case, Adam's case seems to be doing a very good job of reducing client write I/O throughput drops here. We'll have to see in the HDD case what it looks like, but I don't think it's going to make anything worse. I suspect it will only make it better. So it'll be very interesting to see what Paul's tests show. And the read side, Adam and I were puzzling over this morning. For some reason, in the default case, we're exceeding the FIO cap on read IOPS. Actually, we do that on the write apps too. It should be 500, and yet we see it bounce up, and same in the read case. And with Adam's change, it still goes above it, but it's capped at like a lower limit, which neither of us quite understand. Maybe it's some artifact of how FIO does its capping. But in any event, again, we see that in the default case, we drop below the cap more often without Adam's changes. So it all looks very, very good. I'm still amazed by how much of an improvement Adam's changes are making here, and it's also making the structure, some of these data structures simpler by getting rid of shared blobs, which I'm just incredibly excited about. So yeah, that was my read of some of this data that we got. Adam, does that all sound right to you as well?
Exactly the same. I can confirm that the quality of results was so extremely good that we really thought for some time that there might be some error. Hence, you can see two sets of results. One is original branch, and then there is a small fix, but that didn't actually change much. So for now, I'm a bit positive that it might be a real output, and we can have such performance for long running cluster. And as Mark said, that change opens a window to severe simplification of some BlueStore data structure, which I'm always a great proponent of.
All right, that's I think all I've got. Adam, anything else?
No, I will. I can just promise I will continue to, in first step, make an FSCK in sync with this code so I can properly run all tests, and then have some roadmap to put it into a compatible extension to current, because current in today's state it's a bit hacky implementation, but with little effort it can just extend how we organize our objects. For now, I think the easiest solution will be to maybe for some time have both ways of handling shared blobs, and possibly still using that old complicated approach when we have compressed objects. Maybe. I'm even not sure now that it will be ultimately the case, but for now, I would love to preserve that compatibility. That's it.
Cool. So, any questions? All right. Well, then I'll open it up. Anyone have anything they want to talk about this week?
Hey, Mark. Not so much a discussion, but I just wanted to let you know that there's a PR for RGW's HTTP3 front end now. Not working yet, but the prototype is in progress. So that's kind of a performance-related project that I'm excited about.
Cool. What kind of difference do you think it will make?
I think that at enough scale with enough connections and streams, I think that we should see slightly better performance on the server. Faster SSL handshakes, hopefully better control over buffering in RGW. HTTP3 itself has stuff like header compression that's a good optimization over the text-based HTTP one.
That all sounds very exciting. How are we doing now in terms of CPU usage and RGW? Sorry, this echo is killing me.
CPU usage generally, I don't know that I have a handle, but I mean we did a lot of work on the Beast front end and its CPU usage.
I don't know if you can still hear me or not. Close the other browser window. I don't
Yeah, I
hear
hear you
myself
fine.
anymore. Oh, good. Okay, and I don't have an echo anymore, which is fantastic. I know a while back, we had those really big CPU usage numbers that I think you guys improved quite a bit. But that seems like it might be every time I hear feedback from kind of people trying to do cloud deployments and things, they always want the CPU usage of our daemons to be lower. Usually the Ceph OSD is the side I hear about it a lot, but I suspect, especially if they want to scale out RGW, anything we can do there to reduce overhead, CPU overhead, is probably a win. Well, anyway, sounds like it has potential. At some point, I'd like to get back to actually doing a profile on RGW and just see kind of where we're at these days under like a really heavy, small object workload. All right. I don't hear anything anymore. I don't know if that means there's no talking or if it's just I can't hear anything. But
Still here.
Okay, good.
I don't have any more topics.
Okay. Well, if no one has anything else, then I suppose we can wrap up. Adam, I just want to say again how impressed I am with the work that you did. It's really, really impressive how much this helps. So congratulations. I think you I don't know if it's say hit a home run or won the lottery or a home run is
more
better
like
because it implies
more like a lottery, I guess. It's
no,
neither you nor I expected that it have so big impact.
I was going to say I don't feel like lottery captures it though because it was really a result of your hard work, not just random chance. So good job. It looks like your instinct was right. I'm very excited to get your change to Paul to try out because I suspect it's going to be a big win. Hopefully, I'm still a little nervous what the general process of snapshotting and fragmentation might look like on hard drives with this workload, but to some extent we're going to hit the limits of what you can do, right? What we can solve ourselves. here with this approach. So
That's why I think that in the long run we need a defragmenter, because snapshots and small writes will completely break performance on spinners.
yeah, I'm a little nervous that might still be the case even after this, but we'll see where we end up at. Well, thank you all for coming, and we'll talk again next week. And have a great week, everybody.